In the second part of this sort of look at tangent handrailing and CAD handrailing, we're going to look at how the tangent handrail is drawn in the CAD system and the anomalies that that's going to throw up. We're going to use the same dimensions again as we used on the traditional tangent handrailing drawing. We'll drop some numbers on here so we can see where our goings are. The dims for the going, again here, 254mm or 10 inches, and I haven't drawn in the nosings and risers again, the nosings and the spindles, but obviously if they were drawn in, you'd have a nosing along the front of the tread and returning back, with the spindles set over the tread, and the centre line of the spindles is where our handrail is going to run. But we don't need those, so we'll get rid of those again. Our weld dims are the same as last time. We're going to work on a 10-inch going, and therefore, because we want to keep a constant pitch through the turn, we're going to work with half the going as our weld distance between the centre lines of spindles. So our radius will be half of that. So we're down to sort of 2.5 inch radius, 63.5mm radius. And if we pop in a 3D model so we can see the build up of what we're doing, we have the plans there. We'll hide those few dims for a minute because we don't really need those. And then we can drop the goings in with the surfaces to represent our goings. We can have the line up here which shows the edges of all the goings and rises, which is obviously what dictates to where the handrail runs and sets our heights and our turns. We can pop the riser numbers on there so we can see how they relate. Again, so we now have the going and riser numbers here so we can see how that relates. And then we can have our handrail centre line. So the centre line obviously comes up across our intersection between going and riser. So we have these handrail centre lines going back up, and then of course we have the turn in the end here, which is a piece we're trying to look at, and we need to make certain that that stays in the right place around the corner and it hits these right correct heights as we're coming down off the pitches, so everything has to line up. And then what we're going to do to be able to get this, we're going to pop a surface in here so we can draw these handrail pitch lines and the riser and going lines onto these surfaces so we can keep a track of what's going on and see what's happening when we bring it back over. So let's have a look and see how we go about doing all this, and how when drawn in CAD, the tangent system and what it does around this corner as it comes into these straights.